Hello guys, in this video we are going to discuss the solution of the problem 2 swaps. So let us look at the problem statement. The problem statement says given a permutation of sum of the first natural number in an array ARR, determine if the array can be sorted in exactly 2 swaps. A swap can involve the same pair of indices twice. Return true if it is possible to sort the array with exactly 2 swaps, otherwise return false. So for instance, if this is the array which is given to us, it is possible to sort this array using 2 swaps, because of which we are returning true. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem revolves around the fact that every element has a unique position where it lies. So what do I mean by this is, if x is an element of the array, then x must exist at x minus 1th position. So for instance, if x is equals to 4, then x must exist at x minus 1th position, which is 3rd position. And why is this the case? This is the case because the array contains first n natural numbers. Similarly, if the value of x is equals to 3, then in the array this 3 should occur at x minus 1th position, which simply means 3 should occur over here. And the same goes for rest of the element. So using this fact that an element x should occur at x minus 1th position, let us see how we will be able to solve this problem. So to solve this problem, the first thing which we are going to do is we are going to count the number of elements which are not in its correct position. So what do I mean by this is, if ARR I, so the ith element is not equals to I plus 1, then that simply means that the ith element is not at the correct position, in which case we are going to increase our count variable by 1. So count variable will be increased by 1. So and this count variable contains how many elements are not in its correct position. So once we have the number of elements which are not in the correct position, then we are going to check if this count is equals to 0 or this count is equals to 3. So if the count equals to 0, that simply means the array is already sorted, in which case we can return true. Similarly, if count is equals to 3, then it is possible to sort the array by using at most 2 swaps, because of which we are returning true. We are going to explore these cases when we take an example, but for now let us proceed forward. In case where the count is equals to 4, then it may or may not be possible that we will be able to sort the array using 2 swaps, because of which we are going to do 2 swaps over here. So this will be my first swap, and then this will be our second swap. And after doing these 2 swaps, what we are going to do is we are again going to count the number of elements which are not in its correct position. And if this count equals to 0, then that simply means by 2 swaps we are able to sort the array, in which case we can return true. Otherwise, if none of these conditions are satisfied, then we can return false. And that's the whole idea behind solving this problem. So let us go over it one more time. So the first thing which we are going to do is we are going to count the number of elements which are not in its correct position. And how do we determine whether an element is at its correct position or not? Well, this is how we are determining it. If array of I is not equals to I plus 1. So now we have the number of elements which are not at its correct position. If the number of elements which are not at correct position is equals to 0 or 3, in such case it is possible to sort the array, because of which we are returning true. Otherwise, if count is equals to 4, so if the number of elements which are not at its correct position is equals to 4, then we are going to perform 2 swap operation, and after that we are going to again count the number of elements which are not at its correct position. If this time the count is equals to 0, then that simply means by using first and second swap we were able to sort the array, because of which we are returning true. And if none of these conditions are satisfied, then in such case we are going to return false. So that's the general idea behind solving this problem, folks. Now let us take some example in order to understand it completely. So let us take some example. So let us say this is the array which is given to us. Over here, as we can see that the number of elements which are not at its correct position is 0. this simply means the array is already sorted, because of which in this case what we are going to do is we are going to return true. Let's take another example. So let us say this is the array which is given to us. Over here the number of elements which are not at its correct position is 3, and those elements are 4, 2 and 3. Since the number of elements which are not at its correct position is 3, because of which we will be able to swap the elements in order to sort the array. So let us see how we can do that. So for this what we are going to do is we are going to take an element which is not at its correct position and we are going to move that element to its correct position. So for instance 4 is the element which is not at its correct position. So what we are going to do is we are going to move 4 to its correct position, and the way we will be able to do this is by swapping 4 and 3. So after swapping, the array will be something like this: 3, 2, 4. So in this case we have taken this element and this element and we have swapped these two elements, after which the array is something like this. The next thing which we are going to do is, since 3 is not at its correct position, we are again going to swap this. So we are going to take 3 and we are going to take 2, and after swap the array will become something like this: 1, 2, 3 and 4, and in this way we will be able to sort the array. So the point I was trying to make over here is, if count is equals to 3, then in such case it is possible to sort the array by swapping, because of which we are going to return true. So this is a case when count is equals to 0 or count is equals to 3. Now let us discuss the case where count is equals to 4. So let us take an example where count is equals to 4. So let us say this is the array which is given to us. Over here the value of count is equals to 4. So again what we are going to do over here is we are going to take the first element which is not at its correct position. So this is the element which is not at its correct position, and we are going to swap it, or we are going to move it to its correct position. So this is the correct position. So in a sense we are going to swap these two elements. So let us do that. So after swapping, the array looks something like this. So again let us find out the element which is not at its correct position. So this is an element which is not at its correct position. So we are going to move it to its correct position, which is this. So simply we are going to swap these two elements. So let us swap these two elements, and after swapping the array looks something like this: 1, 2, 3 and 4. And after swapping, as we can see, the number of elements which are not its correct position is 0, because of which we are returning true. So folks, over here we have taken an example where count is equals to 4 and we are able to sort the array. But there exist cases when count is equals to 4 we will not be able to sort the array. So let us discuss that case as well. So let us say this is the array which is given to us. Now in this case, as you can see, the number of elements which are not at its correct position is 4, and the first element which is not at its correct position is this element. So we are going to move this element to its correct position, after which the array will look something like this. Again we are going to find out the first element which is not at its correct position. So this is the element which is not at its correct position, and we are going to move this element to its correct position, after which the array will look something like this. And as you can see, even after two swaps the array is not sorted, because of which we are going to return false. And this is the reason, folks, why in this case where the number of elements which are not at its correct position is 4, after two swaps we are again counting the number of elements which are not at its correct position. This is just to check where we have indeed sorted the array, and if after two swap, if this count is equals to 0, then only we are going to return true. So that's the whole idea behind solving this problem, folks. Now let us discuss the pseudocode of this problem. So let us say we want to check sorted and an array is given to us. So the first thing which we are going to do is we are going to count the number of elements which are not at its correct position. So let us do that. So return num unsorted, and an array is given to us. And this function, what it does is it returns the number of elements which are not at its correct position. Once we have this value with us, we are going to check if count is equals to 0 or count is equals to 3. In such case, it is possible to sort the array, because of which we are going to return true. Otherwise, we are going to check if count is equals to 4. In such case, we are going to perform the swap operation. So let us do that. So let us say we want to sort by swapping. So we perform first swap operation over here. After first swap, let us do the second swap as well. So in this way, we have swapped two elements of the array. Now, after swap, let us again check the number of elements which are not at its correct position. So if return num unsorted arr equals to 0. If after these two swap operation, all the elements are at its correct position, then in such case we can return true. Otherwise, we are going to return false. So that's the main algorithm to solve this problem, folks. Now, as we have used these two functions, so let us complete our pseudocode by writing these two functions as well. So let us first look at the return num unsorted. So for this, what we are going to do is we are going to take a count which is equals to 0. And then we are going to iterate on the elements of the array. So for I in range of len of array, and then we are going to check if arri is not equals to I plus 1. If this is the case, the element is not at its correct position, because of which we are going to increase our count by 1. And towards the end, we just have to return count. So in this way, we will be able to return the number of elements which are not at its correct position. Now let us discuss the last case, which is sort by swapping. So for this, what we are going to do is we are going to iterate on the array. So let us do that, and then we are going to check whether this element is not at its correct position. So if arri is not equals to I plus 1. If this condition is satisfied, then the element is not at its correct position. Then arri has to move to its correct position. So let us do that. So for that, temp equals to arri equals to arr temp minus 1, and arr temp minus 1 is equals to temp. In this way, we have performed the swap operation, and once we have performed the swap operation, let us break from this loop, because we want to perform one swap at a time. And in this way, as you can see, after performing swap operation one time, we are breaking from the loop. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. So in the Python implementation, first we are counting the number of elements which are not at its correct position. If it is equals to 0 or 3, then we are returning true. Otherwise, if it is equals to 4, then we are performing the swap operation. And again, we are counting the number of elements which are not at its correct position. If in this case it is 0, then we are returning true, otherwise false. And folks, sort by swapping and return num sorted is same as what we have discussed in pseudocode, so I'm not going to go over it. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. Over here, we are counting the number of elements which are not at its correct position. If it is equals to 0 or 3, then we are returning true. Otherwise, if it is equals to 4, then we are performing two swap operation, and then we are checking the number of elements which are not at its correct position. If this is equals to 0, then we are returning true. Otherwise, we are returning false. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.